Okay, this problem, pick index in a mountain array. Let's call an array a mountain if the following properties hold. A length above equals 3. There exists some I between 0 and length minus 1 such that it increases until I, then it starts to decrease. Given an array that is definitely a mountain, return any I such that increase to I, then decrease. Okay, given a mountain array, we want to find the peak. Let's take a look at the example. For this one, the peak is at index 1, that's output. For this one, the peak is at index 1 again, that's the output. Okay. The straightforward way is we iterate through this array, and we first should meet an increase sequence, then the first decreasing sequence is a peak. The time complexity is O(n), space complexity is O(1). Can we do it better? What we are trying to find is a position that is above left and right. And this point can be found with binary search. Okay. Say for this one, the middle point is 1, which is a peak. We find it. And for this one, the middle point is 2. Again, we find. Let's write up a bigger array. Say we have 1, 2, 3, 4, 5, 7, and 3 and 4. Okay, in this case, we find a middle point, which is 4, and we find this is on a upper slope, so the peak is on the right. So we only have to deal with this half, and for this half we find a middle point, which is 7. We check this one have a is increase and decrease, so this is a middle point, and we can do this with binary search. Okay, let's start code. In this case, the time complexity is log n. Space complexity could be a 1. If we are not recursive, if we use recursive, the space complexity will be log n. But we can use while loop, the standard while loop. Okay, let's start code. Okay, array. At first define low equal. Okay, we test if this is a rising slope. What we have to do is we test the left half. let's see, strictly increase. Okay, no equal, that's 0. That means the slope is on the right, the peak, we're on the rising slope, the peak is on the right of the middle point. So in this case, low equal mid plus 1. Or reverse, we are on the down here. That means the middle point is on the left. In that case, I equal mid. Should we include the mid? Yes, we should include the mid, because the middle point could be right on the edge. So in this case, we either have the left side include the mid, or we have the right side include the mid. Else, we just return, or else we find it. We should return neither up slope nor down slope. Then we are in the mid. Okay. If we missed, let's return low. Let's test this. At the beginning, relents 3, and we go into here. Three minus 0, 3. 3 over 2 equal 1. 1 plus 0 is 1, so middle point is here. Middle point is here. We test this. So this won't satisfy, this won't satisfy. Then it'll return mid, which is 1, what we like. Okay, how about let's supply a little bit complexer example like this one. Let's see what will happen. Let's our low is 0, our high is 1, 2, 3, 4, 5, 6, 7, 8. So high is 7. Calculate 7 over 2, which is 3. So this is our middle point, 3. 0, 1, 2, 3. This is our midpoint. And we test. It's on the upper slope. Yeah, this will hold. So low equal mid plus 1. Low became 4. So 0, 1, 2, 3, 4. We are handling this half. Let's put our low here. Again, our high is here. And let's recalculate the mid. The mid is 4 and 7. 7 minus 4 equals 3. 3 over 2. 1. 1 plus 4, 5. So let's go to 5. 0, 1, 2, 3, 4, 5. Our midpoint came here. And let's calculate. This doesn't match. This doesn't match. And so it have to be this. So it'll return 5, which is what we want. Okay, this works. How about, let's put a special case. We just, the mount is at here. Let's see what happens. And again, start from 0 and 1, 2, 3, 4, 5, 6, 7. Okay, this is 6. Middle point we calculate is 3. So let's move it to 3. Oh, let's put it back to 0. 0, 1, 2, 3. So we put it to 4. And we calculate. It's on the upper hill. So we calculate low equal mid plus 1. So that is 4 again. 0, 1, 2, 3, 4. Low equal 4. High doesn't change. We go back. Recalculate mid. Mid equal 4. And plus 6 minus 4 equal 2. 2 over 2 equal 1. So 4 plus 1, 5. This is 5. Mid equal 5. 0, 1, 2, 3, 4, 5. Mid go to here. And again, let's calculate the left and right. We are return 5 again for this case. And that should work. Let's run it and see. Yeah. And we just achieved the goal with time complexity 1 and space complexity 1.